I'll try to see if we can manage some application also. Okay, so let's see if we can have some time for the application also. A theory is there, so we have to understand the different algorithms we have. So I have already done that. Let me start now. The first one is your naive Bayes algorithm, classifier, and there's a supervised learning algorithm. So it is based on Bayes theorem. So if you have studied Bayes theorem, it's okay. Otherwise, I'm going to tell you in any case. So, but it depends on that. And the Bayes theorem is something like, let me paste it first. I normally prepare the things so that I can paste it here. I don't go it directly. Do that also, but that's okay. And let me put the formula also. This is an image, so it should not be an issue. Okay. As we have already seen, okay. When we put an image, it is like this. Okay. Now let's see. There's more to it. So it is also known as Bayes theorem, is also known as Bayes rule or Bayes law, and it more or less all the machine learning algorithms are on probability. So this is also on probability of a hypothesis of a prior knowledge. That means it must be having some knowledge about the things, and that is why it is a supervised learning classification algorithm, and it depends on conditional probability. The formula is like this: PAB, PBA, PA, or divided by PB. Okay, so let's see what it is. What we mean by these things. So there are probabilities. So what type of probabilities we are having? We have to see these. Okay, let me paste it. There are four things here. So let's see. Okay, so let me put these two first, A and B. Will be better this way. Messed up. This I can do later. Okay, so we have PA, that is prior probability. Prior probability, that means it must be knowing in advance. So even before the data is collected, it is having some knowledge about it. Like if we are talking about a spam mail, so what is the probability that a mail is a spam? Okay, even before it would be knowing that the algorithm or my model would be knowing that this particular mail would be a spam mail. And how would it know? It would be looking for some keywords, right? Some promotional keywords we have, and we have seen in Google Gmail also that it puts your mails, some of your mails, into spam. And the reason is because of the either because the subject is missing, one, that may be the reason. If there is no subject, it is by default it goes to your spam sometimes, most of the times rather. Only in some cases it will be reflected in your inbox, otherwise it will go to the spam folder. And otherwise there are some promotions, or there are some keywords which already Gmail knows that if these keywords are there, then it has to be a spam mail. So even if you write a mail and you think that it is an authentic mail, but you find that the person to whom you have sent has not received the mail, and then you ask the person to check the spam, and the mail will be there. And the reason for that is because you must have put some keyword in it which according to Gmail is a spam. in the content or in the subject, right? It normally checks the subject and but it takes the content also. Right? So if it finds a keyword which is according to Gmail is a spam, so it will put it in that. So that is your prior probability. That means it already knows what is a spam. So whenever a new mail comes, it will check and put it in the spam folder. Very simple. And that is what an example is. We have given the example. And then marginal likelihood. PB is marginal likelihood. It is also called evidence, or you can say probability of evidence or event to occur. Like money, if you put P money, is the probability of mail include money in the text. So if we put P money, that is probability of money. That means the mail includes money in the text. The money should be there in the text. Okay, just an example. Okay, now we have PAB. A slash B, you can say A mod B. It's not mod actually. A slash B. It is posterior probability. It is a probability of the hypothesis A on the observed event B. Okay, this is a probability of A on B. Okay, so we can have something like, if we say P spam money is the probability mail is spam, given that the mail includes money. So two things we have given here, that a mail would be a spam mail if it has money keyword in it. It could be anything. It is just an example. So that is A on the event B. A, the probability of A on B. That is what is the probability of a spam if it contains money in it, right? So that is PAB. Now PBA will be the likelihood the other way. Likelihood probability, that is probability of evidence, given that the probability of a hypothesis is true. That means if we have P money spam, then the probability of money that mail is a spam. So what is the probability that a mail containing money would be a spam mail? So it is not that the only one keyword would be enough. It may be looking for more than one also. It may be looking for the probability, what is the probability, and it will figure out and then put the mail in a spam. And I can put this also uh, in the algorithm, in the formulation, sorry, and show you. It is like this: P spam money, P money spam, P spam divided by P money. This is how the naive Bayes algorithm calculates the probability of occurrence of an event, the probability of fetching an event. So what happens actually in real time when I give data to my algorithms? What I do, I let's say we have an Excel file. We normally have a CSV file, which is also a type of Excel only. It is comma separated file. CSV file is a comma separated file, and that means after each you can say, what do you say, that column you can say, okay, or even after each word or a sentence, suppose you have a comma, that is a comma separated file. So it knows that the separator here is a comma, so from there it is going to fetch the data in each column. So it is a comma separated text file, sort of text file. You can open the CSV file in a notebook, or you can use Excel to open the file. So you can use the way you want, but most of the time in datas you will find it is a CSV file. You can use any file actually. You can use a text file, you can use an Excel file, you can use a PDF file, you can use a SQL file, SQL file. You can use anything you want. There are different things. Even a document file, a doc file, you can read. I'll tell you how to read these files, but these are there, and you can open them. We have the modules to open these files. and the data is used for classification, for probability analysis or something you want to do, regression or whatever you want to do, right? So if I give my algorithm or my model, a machine learning model, this data, so my data will be in columns like we have in Excel file. Just imagine an Excel file having some columns, X, Y, Z, some columns are there. Let's say 10 columns are there. The last column will be the class. That means if this is these are the things, then the class is what. So if we have some keywords in these columns to find that this mail would be a spam mail, then I will be putting some words, keywords in each column, and then mark it as spam, non-spam, or doubtful, or something promotional, or whatever I want to do. And these keywords, actually, my system has learned over the years that okay, if this is a word is there, then it has to be treated as a spam mail, because sometimes what happens, I can put it in a spam myself also, so I can transfer it, and I think that this is a spam, so I'll just put it in a spam folder. It will disappear after some time, or I can delete it later, or I can delete all the spams uh, at one go also. So that is the choice, it can be done. And now since I have let's say a CSV file now with some data in it, and the class as spam or not a spam, or a clean file, or whatever keyword may be there. Now when I put it through my bias model, it knows, it trains, tests, and it knows now that this type of content would be treated as a spam content, and it will put it in the spam folder once the new mail comes. So when the new mail comes, it will check whether the keywords are there or not. Now the questions comes, why we can do this if you are a programmer. I would say that this can be done using if else also. I can put the keywords in a file, or I can put it in a data in my data, and I can simply browse through it and check whether the word is there or not, and why I need a classifier for that. Yes, you can do it, no doubt. But if the data is huge, like if you have some 1 million words, then what will you do? It will take ages, because in that case, if else is okay. The number of words, how many words will you give? So that is a challenging thing. It can be done. It is not that it cannot be done, but it is not practical to do it. It will take a lot of time. And once you have a classifier which already knows what is what, it is the classifier is like your you can say a person, a lawyer, you can say, who knows the law, and who knows that okay, fine, this is not correct, this is correct, and put it in the right place. Okay, you can say anything. For the sake of example, I just took the lawyer. It could be a policeman also, it can be anyone. So so my data, once it is classified, it is easier for me to get the probability whether in this case the mail is a spam or not, or it may be promotional email, advertisement, or something like that. It depends on the data I have trained on my machine learning algorithm, like naive I've used. Naive is actually very simple algorithm, very very simple. As you can see, it is like if else only, but it has shown good results in the past, and you can say that it is good, but it has its own limitations also. And we will see that when we will compare these algorithms practically. We will run them all, most of them, one by one on the same data set, and see what happens. Now when we run these things, you will understand that not all the algorithms would give the same result. some would be better, and some would be not that good. So naive bias does work on textual data. It does work well, but if it is something else, numeric data, you can say it is okay. And in some case, textual data also, but the data set is small. These machine learning algorithms are okay. And naive bias is also a machine learning algorithm only, so it will be okay for it. But again, the data, it all depends on the data, right? Okay, now the next one, which is something like a very hot thing, and I'll tell you, and I'll show you the application. Implementation also, but not now. Let's see if I get time today. I'll get time. I think there's nothing much here. I've already opened the implementation part also, so it should not be a problem for me to take this today. Already implemented that, so it's not an issue. Okay, now let me one letter. Here is K. Okay, K-mean clustering algorithm. It is unsupervised learning algorithm. It's a clustering algorithm, you can say. Now, when I say cluster, that means a collection. Okay, so if you think that things, you can imagine that they're put all together, or it finds the things which are likely to be the same. And let's take an example, then I'll go through the theoretical part. Let's take an example of a crowd. Okay, so in that crowd, if you want to separate the things, you can put the clusters, like those who are tall, those small, then the girls, then the boys, then the age group also. So you can actually find a cluster of things which are seemingly same. Okay, so it may not be same, so it may be similar. You can say similar things, right? So k-mean clustering, actually, it is unsupervised learning. We know, as I have already told you. So that means you are not telling it in advance that what is what. That means it is not. I don't know whether it is a spam mail or not a spam mail. Just carrying from the example which I took for naive bias. So I'm just telling you that. Okay. So it it categorizes the data. Like I told you, gave you an example of a group. So sorry, a crowd. So it will group the things according to the categories, of the probabilities, the features. You can say according to the features. Okay. So the algorithm here works on the principle of finding the groups within the data, likely groups. That means the similarity groups, similar groups. Okay, so number of groups here are represented by k, uh, and then iterates, it loops, assigns each data point to one of the k groups based on the features. Like I told you, we have to get the features. Like in case of a human being, the features would be the height, and could be the age, right? The gender. So there could be many features in a human being. So if you look at it, so in that case, likelihood, what is the probability that these things would be same depending on the features? It clusters into groups. It groups the data. That is why it is called K means clustering algorithm. K is a number of groups it will divide the data into, right? These algorithms, some of the algorithms like k-mean, you can say, they have originated actually from the idea of network. Okay, so networking clustering is done, and we find the nodes having the similar features, like bandwidth and all according to that, and the data is passed on, and how the data is shared. So it has something like, if you know wireless signal processing, we have leech and all protocols are there, certain protocols are there, and they work on clustering. They cluster the things together, and if something fails, then it passes on the information or its responsibility to the other, something like that. Okay, so let's not get confused. Just stick to the data, because wireless sensor processing is something different. Although I have worked on it also, and I can explain also, but no point taking it right now. So let's talk about the people or the machines. You can say similarities. It will find the features. When we say features are something like, we have human being, like it can be eyes, nose, skin color, lips, ears, hair, height, definitely height, weight also. Okay, the gender. So features are like that. So in a data, what feature would be there? That is very interesting. If it is an integer type of a data, what features would be there? Because it is easy to find features in your mm, objects rather. In objects like images, it's very easy to find the features. You have the colors and all, but in data, it is just a number. And interestingly, everything is a number only. Even an image you must have seen is a number only. It is a matrix of numbers, right? So, but in that case also, the color variations are having the different numbers. So it is easy to classify an image or a video or even a voice, because it also has certain decibels data there, and we know that, okay, fine, if the range is this, the what it could be. But in case of simple numeric data, we have to find the similarity, and that is very easy. It can be found. It is actually the numbers which are matching, which are close to each other. Like if you have the marks of the students in a class, you can easily find who is scoring about 60, who is scoring about 90, who is scoring about 80, right? So that is clustered together. Okay, so that is there. So you can have something like that also. So k-mean clustering can be used in a lot of places. Now comes the very important. Actually, everything is important, but this something is was the favorite of most of the faculties, actually, I would say, and the researchers, that is called SVM, State Support Vector Machine Algorithm. Although my experience with SVM is not very good, I did not find it very interesting, as my data was not classified sometimes properly, or maybe I was using it on some other forms it doesn't support much, so that could be the reason. But although this is not a very say that was not a very interesting thing to get the data, the results, but it is something. If you look at the papers in till 90, you can say 2000, you can say, you will find a lot of SVM there. Lot of SVM. People were using SVM like anything. And the reason was, we had a tool which could be used with the data. Just put the data in, the tool was there, and you just give the parameters. You give the, okay, this column is what, and the tool could actually find the probabilities, the classification. It would classify easily, and SVM was used there. So it was the hot favorite of the researchers for a long time, almost 10 years, you can say. If if you find between 1990 and 2000, you'll find that this was growing up. And not 1990, you can say 95 and 2005 years, you can say that. Even after that, it was used a lot by the researchers and the professors, and they were very keen on that. And even today, some of the old professors would tell you that you should be checking on SVM also, and get the results and all. It's easy, but the results may not be very attractive, not what we would like to have. Because today, SVM, if is giving me an accuracy of 70%, 60%, which is actually okay. Anything above 60% is okay. Accuracy, okay, let me tell you, I use this word accuracy. So when we actually classify the data, we check whether the classification done is accurate or not. So that is where we calculate accuracy, and we have a few formulas for that to calculate the accuracy. And I'll be taking that when we will calculate. So we have the formulation, we can calculate the accuracy. Actually, it can calculate directly. We have now the modules for that, and it can calculate. But we have true positive, false positive, true negative, false negative things there, and we find the precision, the recall. These are all mathematical formulations, and according and depending on that, we get the accuracy. So, and there are more things like F1 score also, and that will be taken later. And my algorithms can find that directly. These days, modules are fine tuned, and we can always find them directly. So SVM is okay. Support vector machine, it is a supervised learning classification algorithm. Like your naive Bayes, you have to tell that the data belongs to this particular class. Okay, so it also divides, filters the data into categories, like your clustering algorithm. So, but for that, it needs a training example. Okay, so we have to tell that this category belongs to this. Like I had given you an example of a person walking on the road. The person may be walking fast, maybe slow, maybe running. So I have to tell, okay, fine, if this is the data I get, then this person would be running or walking fast, slow, or whatever, right? So this is what has to be given to SVM also, like we give to naive Bayes also. So now the once it is given, and once it is trained, so it actually builds the model and assigns new values to each category. Okay, so it will be giving to the categories the new values, and once you give the new data, it will actually tell you what is what. It will be able to classify and find the probability whether the new values you have provided belongs to a particular class or not, or what class it belongs to. You can say that like that. Okay, so if you have some let's see, all these examples, you can imagine a library, all these algorithms, something like library. And if we have got some new books, okay, so we have new books, and what will we do? We categorize the books and put them in particular shelves, right? Like we have to put your AI books in one shelf, then we have to put, let's say, biology books in one, the others follow, right? Similarities. So similarly, these machine algorithm also work similarly. Like you have like SVM, in this case, we already train my system to know that this particular thing or this particular book belongs to AI. This particular book belongs to bio. This particular book belongs to mathematics, physics, and so on. So it already knows. So once it gets the new book, it will be able to put it at the right place. So most of the algorithms are working like this only, whether they are working on features, okay, or whether we are working on already specified supervised learning, like you have already told the class, whether you are using the whichever method you are using, the output or the end result, or you can say the aim of my classification is similar to what we do in a library. Okay, whatever you do, the end thing is to put the right data in the right shelf, right? Right place you have to put the data, and once the new data comes, you find, okay, this belongs to what, right? In this case, some cases, like if I know that this book is AI, it's written that it is AI, then it's very easy. But if there is something which is written there and I do not know whether it the keywords belong to AI or not, but I'll find the probability, what the probability matches. Now if the probability the keywords matches with the AI, I'll put it in AI. Similarly, my data will be on probability only, the matching probability. What is the probability that it matches, and it puts the data, or the it classifies the data accordingly. Okay, so now let's move to another algorithm that is called linear regression. Linear algorithm, we can say this is your mathematical, actually they are all mathematical. It is a very basic type of regression algorithm. The simple linear regression between the 2 points. If you have point A and point B, if you have read it in studied this algorithm in the mathematics, you must be knowing that the curve it gives between A and B. So that is what it is supposed to do. It tries to understand the relationship between point A and point B. Okay, so this is another way of getting to know the relationship between A and B. And linear form, it is in linear form, state form. So that is why it is a linear regression supervised learning, or a regression algorithm. And most we have seen what is regression, what is classification earlier. So I'm not taking it right now. But if you have any queries, you can drop the message. I'll tell you. I'll revert to you. Anyway, so linear regression is okay, and in some cases I found that this equation works better than many algorithms, but in some cases again it won't work the same way. So that we have to see and check. It all depends on the type of data you have. Okay, so what normally I do is I take the data and put most of the algorithms and check what is which algorithm is giving me a better result, and then I use that. So it depends on that, because there is nothing much we can do with the algorithms we have. Only we can do whatever we can do is with the data that we can do. Data we can manipulate, data we can actually clean, we can put the data, arrange the data in such a way that I'll get better results. So that can be done. But algorithm only parameters are there, so you just have to put in these things, and then you have to tell, okay, fine, this is what we have, and now you work on it. Now I'll just explain a few things before I proceed. When I use a data, when I say data, so data numeric is, let's say if you are talking about sales of a company and I want to predict the future sales, I can do that easily using any of the algorithms, right? Any of the machine learning algorithms. But what we do, we take, let's say, 10 years data, sales data of a company, and the data should be big, not very big. If it exceeds a particular limit, then let's say if it exceeds 1 GB, so it may not work. These machine learning algorithms may not work properly. Then I would be requiring something else, right? I would be requiring deep learning, or if it is more than that if it more data which a deep learning algorithm can handle, then I would be requiring transformers or I'll have to manipulate my data. So when we have the data, let's say I was talking about sales data of 10 years, and we know the sale every month. Okay, sale of every month, let's say, is the class, and the year definitely year and the month. That is the class. Now, what I do, let's say I have 1 million records, 10 lakh records, right? What I'll do is I'll divide the data into training set and testing set in a ratio of 80 is to 20 or 70 is to 30, depending on what type of classification, what type of results I want, and I can do that. And normally the data is taken from the same these days. Earlier we used to have a training set different and testing set different, but these days for the last 4 5 years it is recommended that you should take the data from the original set, only divide that original set into training set and testing set, and it can be passed through the model. Now, training set and testing set. Now, when you say I'll divide into the 70 30 or 80 20, you may be thinking that the years or the dates may not match, then how the things would be the same. Like, suppose if I take these last 2 years, sales for last 2 years cannot be compared actually with any of the sales over the past years. It may be very, very high in some cases, but it may be very low in many of the cases, and the conditions are not same. So when we take the data, the conditions should be similar. If the conditions are not similar, then the probability is something which will just throw the data anywhere. Even a difference of 0.5 or 0.05 can give you a disastrous results. This probability, right? And I've seen it working also. I did in my practicals, and I found that it was giving not giving the proper results when there was a difference of points more than 0.05. So that is one thing. So what I was saying is that the conditions should be similar, not same. The conditions should be similar. Like we have emergencies in the last 2 years, and things have changed altogether. So you cannot compare anything now. For now, it is just we are surviving. We cannot actually say even your study, what you are studying today and what you could study 2 years back cannot be compared, right? Like you have the classes, regular classes and all, but now the classes are there. Definitely, there are the classes are there, but it may not be the physical classes. Although I was taking the online classes for a long time, so it's okay. But then the interaction is not there. Interaction of the people, the social development of the child is not there, so it cannot be compared, right? The things cannot be compared with the quality or with the quantity today with something 2 years back, right? So all in all, the thing is when we are taking the data, we have to make sure that the conditions were same or similar. Okay, it may be plus minus because but it has to be similar, right? Cannot be the same, but it has to be similar. And if it is a vast change, like we have the lockdowns and all, then it cannot be compared, right? So once I have the data, so when I divide it into 80/20, it is not that it is like first 80% is taken as the training set and the last 20% is taken as the testing set. Then it will defeat the entire purpose. My algorithm, my modules, my codes are written in such a way that it takes the data randomly, right? And we have options where I can actually fix it also. Like if we have a binary data, if I have 0 1 0 1 is binary, 0 is false, 1 is true. Suppose I have a binary data and I want to divide it to testing set and training set. Now what happens if I just divide it into 80-20? So 80% maybe like first 80 must have let's say 60% true. Then the remaining part won't be having the same ratio, right? So what I can do is I can fix it in such a way that whatever the ratio divides, the ratio of your true false, your binary data should be same, right? In case of binary, it can be any other data also, right? So you can actually fix it and you can manage it. So it is on probability. It will just randomly take the data and it will make sure that the division is equal ratio is. Even if it is the 80-20, the ratio, it will try to maintain the ratio. So we can fix the ratio also. So that we have. Otherwise, then the results would not be actually accurate. It will be simple assumption, which will be not actually good. It may give you a very good accuracy, but actually reality would be quite different, right? So 80-20, I divide training set and testing set. Once I train my data with training set and testing set, I have an output which I can use to predict the future data. That means I feed in the new data and the output which I have already generated. It is matched with that. The model now takes that as the input. Training set is already there, and now the authentication or the validation set, you can say the third set is could be the validation set. It works on that, or probability set, you can say that. New set, you can say whatever name, but it is normally called a validation set, and you can put that data now and check, and it will tell you whether it belongs to particular category or not, or what could be the future thing, right? So you already have the data with you and the output with you, right? So this is how all the algorithms work, and the technique can be different. That's all. The technique could be like clustering, could be linear regression, mathematical simple pure mathematical algorithms. Then we have probability like naive Bayes. So it could be anything. It could be anything. Okay. This setting and all I'll do later. Let's not waste time on this. So linear regression we have done that. Now we have logistic regression also. This is again supervised. Linear was more on mathematical. Logistic regression is also there. Okay, paste it first. This is on binary data actually. It works on binary. So logistic regression, it again estimates the probability of an event, but based on previous data provided. That is, it already has the classified data, and it actually it is used to cover a dependent variable. That is where uh, only two values, 0 and 1, represent outcomes. That is binary, because it works in binary. So logically it checks, and it focuses on estimating the probability of an event, occurrence of an event, you can say. So it works on binary data, 0 1. We have to provide that. And the interesting thing is, if you have text and you want to classify that text, then how will you do that? Because it is just a text, it is not a number, and all of them are mathematical equations or algorithms. What we do with the text, actually, we vectorize the text. We convert the text into numbers, vectorize them, and then we use them. So vectorization is there. Otherwise, so you just see how the text can be classified. I can do it because, but if it is huge data, then how will you classify that? So it is actually vectorized. We change them into numbers, and then we work on that. Okay. So basic thing is there, and then comes your ANN. It is favorite of most of the programmers these days, researchers. Although neural network is nothing new, but it is more close to the human intelligence. Artificial neural network, because we develop it, we designed it, and it works on the principle of our brain. Basically, how our brain works on that principle, and I'll be showing you someday the neurons and all, how they work, and that will be done. But for now, I'm just telling you that is artificial neural network. It is a reinforcement learning technique, and here the neurons units, they're arranged in a series of layers. We have layer system, and from there only deep learning and transformers have evolved. And when we say layer, let me just explain you a simple example of a brain. We have a neuron, that is where the memory is stored or the commands are stored, and then these neurons are connected with millions of other neurons. That is, one neuron is connected to other neurons, and that is also millions. So we have 10 billion neurons or something like that in a brain. A billion or I'll have to check. A billion now. Okay. Yeah, it should be billion. And those are again connected with millions. So we have billions of neurons in our brain working, and those who have, you say that sharp brains, actually their neurons are very active. There's nothing much. It's only all about neurons. They work more, or you can say it, they works better than the others. Oh, so you can say that person is intelligent or something, because his neuron is working actually in a better way. Okay, so we have something like this, and what we have to do in ANN is we have to create some similarity between the brain and the algorithms, the codes we are writing. So what is done is actually the layers. It works on layers. The layers are built, and they are connected with each other. uh, so it is actually, as I said, it is actually inspired by what our brain is, the biological system. They are interconnected processing elements which are working together. You can say like this to solve a particular problem. And as I told you earlier, also we have the learning is like back propagation, or a forward thing, that is learn from past and learn from the present, and then you just combine. So layers also, actually I put the data on a layer, it learns on that, then it pass on, connects with another layer, and passes on what it has learned to the other layer. Then it passes what it learns from that data is passed on to the other layer. So suppose if I have three layers, so it is like filtering out the things, right? If you filter out things, the data will received at the third layer, let's say, would be not having irrelevant information. So it cleans that, cleans, stores, cleans, stores, and learns. Clean, store, learn. It is something like that. Okay. So interconnected things are there, and if they pass, just keep on passing the things, and it will be stored. Okay. They actually learn by example or from experience, and very useful for non-linear relationship in high dimensional data. That is, if the data is huge, it's big, then they are the best options we have. ANN, and most of the work is on ANN. All these days, like recursive neural network. And ANN is not one algorithm. Artificial neural network has many algorithms in it, right? RNN is one of them, and LSTM is another one where it is connected with it. Part of RNN, I think we have already told you about LSTM. So LSTM is there. So it is another recursive neural network. So the ANN has a lot of branches in it also. So there are many algorithms in ANN. But we just have to understand what the ANN is and then how to apply that. That is important. Okay. Then we have another one that is called this decision tree, supervised learning classification algorithm. Mm, we call it CART also. Sometimes. All right. Let me now. I'm not sure how many of you would have done the flow charting, but it is like a flow chart algorithm with the branches, and uh, it the branching actually methods are used to illustrate every possible outcome of a decision. What is the probability? What is the probability of getting an output? Each node, it is like a tree, a tree structure, and each node represents a test on specified variables, and each branch is the outcome. Okay, so node is like your branches, and you can say the leaves, you can say leaves. Nodes, you can say, are the leaves, and then we have the branches which are having the leaves, so for the output. Okay, so decision tree, as the name suggests, it is tree like structure only, and it is like you can say flow chart, like a tree structure. If you have seen a flow chart, you must have make designed some charts, flow charts. I'm not sure, because if you have not done programming, then I'm not sure if it was taught or if you ever used. But I'll show you in the coding itself that how we use the flowchart. So it is like a flowchart thing. You can imagine a tree with branches, which are the outcomes, which are having the leaves and the leaves. I'll give you an example, interesting example. It's just clicked in my mind. Now you have, if you have seen lychee tree, I'm not sure whether you have, but it is there in Pune also. If you have seen a lychee tree, or I'll just tell you about a lychee tree. Once one branch gives a fruit, it won't give in the next season. It is very interesting. So whatever outcome you have got from one branch will not be the same in the next season. So what normally is done is we cut down that particular branch once the season is over. So the branch itself is cut down, or a part of it is cut down, and the new leaves are left for the next season. What is a decision tree is interesting thing. You can correlate with that. So how it learns. So the my tree knows, okay, fine, I have already this particular branch has given the fruit. So next season it has to take the rest. So next branch, the new leaves, having a branch having the new leaves will be giving the fruit next season. So it is something like that. So we have branches, and then they're subdivided into branches also. So you cut down, chop down what is already used, and new branches will come, and the fruit will be there. So it is decision tree is there. Then comes the favorite in machine learning, and that is called random forest these days. It's not these days actually. 2 years back, it was a hot favorite. But random forest is one algorithm which has always given good results. But again, I would say may not be the same for every data. So it depends on the data, what the features we have given, and on the features we have to see what outputs it is going to give. So this is decision tree was just the tree, and this is the entire forest now we have, right? So the entire forest has come. So let's see. We'll talk about it 1 minute. They're all very easy to implement actually, because these modules simply you can use them directly. So there's no rocket science in using them. Just have to call them. You should know how to use. Otherwise, not big deal. Once you know one algorithm, you can use any algorithm. Okay. Anyway, so random forest or random decision forest, it can be also called random decisions because it is taking randomly. It is ensemble learning method, and it is a supervised learning classification and regression model. It combines multiple algorithms. It is not only one. That is why it is called a tree. Okay, so it combines multiple algorithms to generate better results. Now, suppose I told you that if my one algorithm may not give a very good result, or it is not actually not giving the output which I want, that means my accuracy is not very good. We actually calculate on accuracy only. So if the accuracy is not very good of one algorithm, what I can do is I can pass my data to the other algorithm, same the output of the first algorithm to the next, and the output of the second to the third, and I can get a better result. So that is done manually also. But random forest actually has inbuilt algorithms, not the same algorithms, but it has algorithms for classification, regressions. So it doesn't work on only one. That is why it is called a forest. It is a forest of different algorithms, right? So individually, the classifier could be weak, but when you are putting them together, they can give better results. Okay, so the algorithm this algorithm starts with a decision tree, the one we have seen already, and combines other algorithms, takes the output from there, passes on to the next algorithm, and then it gives you a result. A better result would be, it could be expected with random forest. That is why it was the hot favorite in machine learning. In machine learning, this is still the hot favorite, although people are moving ahead with other type of AIs, like we have LSTM and all equations are there. So a lot of things have developed over the years. So deep learning, transformers, the things have changed. So people may not be using random forest, but in some cases, I can tell you, random forest can give you better results than any other algorithm. And I have used most of the time random forest also with audio, with videos, with images, and with textual data. With textual data, it may not be the good idea. It may not be giving you the best of the results, but still, it is good, right? So we have different options in these days, but it used to be the favorite. Okay. Now we have after random forest, we have the nearest neighbors supervised learning algorithm. It is something like what we said, like in KNN, K nearest neighbor. Okay, it is nearest neighbors or K nearest neighbor, the same thing which we have done. Let me see if it is the K nearest neighbor. KNN we have already done. Hmm. This is the same thing, so let me just remove that. I'll put it there. KNN actually it is a repetition. I'll just remove this. Nearest neighbor or K nearest is the same thing actually. So I've already put it there. So what I can do is I'll just upgrade this KNN. Put this. data here. Just more example, nothing else. So these algorithms we have, there are many more algorithms, but let us see how we can implement them. Okay, so I don't want this. I'll be using now the tutorial. I already have the algorithms collab I have. Then I'll tell you what essential tools first we have to see for machine learning. Okay, this is more interesting. And let me put the label there. So we need essential tools for machine learning. So essential tools are, first is Numpy. Okay, I'll just put it here. The module is Numpy, which is commonly used. We use it earlier also. So what you have to do is, since it is we already have a collab, so I cannot. One minute, I have got a call. I have to wait. Hello, hello. I'm busy right now. Okay, okay. Sorry, there was a call, so I just took it. Anyway, now, so NumPy, we use numerical computations. You can use, and how we are using it. NumPy as NP, and then we have the array. We have already seen this, but I'm just giving you here again using the format command. So I just paste it. Okay. Run it, you convert it into array. The list into arrays. First time when you run any command in Collab, it takes a little time. So it is taking little time, but it's like that's okay. After this, it will be okay. So NumPy we have, then Skippy we have, Scikit we have, then we have Pandas. NumPy and Pandas, two things we already always need. We are using Collab, so we don't have to install it. Otherwise, you will have to install the modules, right? By default, it won't be having your ID development, integrated development thing will not be having these things. Then we have Skippy. Okay, let me see if it is installed already, but it should be. Okay, from Skippy import. I'm just telling you the application for the sparse matrix. If I want to generate that, in this case, okay. This I have put the commands also. A two-dimensional NumPy array I can create. Okay. So we create a 2D NumPy array with a diagonal of ones and zeros everywhere else. So I is equal to numpy.I. I is the command numpy.I 6. So this is what you are getting. Now convert the NumPy array to Skippy sparse matrix. We convert it into a sparse using sparse because you have already called sparse. So sparse.csr matrix, that is your uh, compressed sparse matrix. Compressed. Okay, CSR is compressed sparse row, and then you're generating the matrix I, and you have to print it and see. Okay, see. So this is 1000, and the sparse matrix generator is this. How we are going to use it, I'll tell you later. But if you want to generate a sparse matrix, then you can use Skippy, or you can use coordinate format we have to generate the same thing. If you want to generate a sparse matrix, you can use coordinate thing also. That is COO. So we have some data. Just to avoid time, I'm just pasting it. I can do it. It's already there with me, so I'm just pasting from there. So Numpy that once, that is the matrix generated will be of ones on the diagonals 1111. Okay, now row indices np dot a range, and the column indices we have given, and then I sparse dot co matrix data row indices column indices, and then you can generate the data. You can see this. This is the representation, and just we have converted into dense form from this to this. From a sparse matrix to dense matrix, we have created using ICOO dot to dense. ICO is the output of the sparse matrix. Okay, not mathematical, nothing else. Just showing you actually how the tools are used, that's all. But you may not be using sparse matrix at all. The other one is you have some arrays and you can convert it also. You have a compile array, RCD, then sparse.co matrix D, RC, row column, and the shape you can give, and then you can print and see, and again you can convert it to tens. So we have different ways of doing it. Then you can duplicate entries. This could be used actually in some of the duplicate entries and see what's going on. So we have common things, and I'm using the same thing again, and we can find the sum. You can see this one output 1 minute. Okay, 0310. So this is what has generated 457900. This is 4. Now you can see the 4 is there. So it actually 00 has 0 has 3 entries, 1, 2, and 3. 0 has 3 entries, right? So, and 1, 2 has 2. The values are summed up, so we can find the value there after summing up. How many times? 00 is 4, 3, 1, 5, 1, 3, 7, 0, 2, 9. That is how it is distributed. 00 is this address, then 0, 1, 0, 2. This is 9, then 0, 0, and so on. It is actually summing up the values and finding out how many times what is occurred, what has occurred. It will give you the results. I'll show you with another example where I've used only zeros and ones so that it could be clear to you. 3 is also there, but that's okay. You can see 0, 0, 0, 0, 2, 1, 1, 1 3, 3, 1, 1, and 0, 0. So 1, 1, 1, you can have something like 3, 0, 1. So how many times it has occurred, and accordingly you can get the tricks. So it can be used to manipulate the data. And then comes the most interesting of it is matplot. For any data analysis, plotting is a must. Matplotlib, you can say. So now import matplot has already come. So import matplot lib.pyplot as PLT. PLT is for plotting. It can be any other thing you want to use, but normally people use PLT, so I have also used PLT. Now let's generate some data and then plot it and see how it is going to work. So generate a sequence of numbers minus 10 to 10 with 100 steps in between. So np.linspace minus 10 to 10 minus 10 to 100 with a space with a step of 100. Then we create a sine wave, create a second array using sines, then np.sine of x, and then just have to plot using plt.plot. And on x-axis what you want, y-axis what you want, and the markers if you want to give, you can give the markers also. See, this is a sine wave you have generated. X-axis and y-axis, you can see the data, how the data is placed. See, so you can generate your data and you can use your data and simply plot any pandas, then the Numpy, Skippy, Matplot, pandas, very important. So I'll just put some text for pandas. Okay. So something like this. The data has headers. When we are using, like we are using a CSV file or an Excel file, it could be having some headers in it. So you can use something like this: program, student, teacher, advocate, professor. We can store it like that. Let's see how we are going to use pandas. So we have a sample data set. We'll be using something like this. I'll just print the data first. This is like your dictionary, okay? Name, labels, and the values. Name you have Amit, Shreya, Himani, and Vivek. Location you have USA, Dehradun, Delhi, and Meerut. Age is 24, 23, 27, 51. Now this actually has no value as far as representation is concerned. It's not properly represented. Now, if I want something like in a tabular format, I'll have to convert it, and to convert that, I'll have to convert it into a data frame. So data pandas equal to, we have the data, okay, data we have. So we need pandas as PD. We have imported or not? We have not imported. Okay, so we'll just import it first. Import pandas as PD. Shortcut we normally use so that we don't have to do a lot of typing. PD dot data PD dot data frame, and you put the data in this. Oops, sorry. Right. Now I'll print. I normally copy paste variables. Just run it, and you can see it is more meaningful now. It is tabular now. Name, location, and age. It has fallen into now the tabular format, and now it is easy to understand. Otherwise, this data won't be very clear, right? So, and our data is normally into data frames. When we are predicting, we are doing any analysis, so it has to be in data frame, and we can convert it using pandas. If you're using the data from Excel sheet or something else, you can easily read that. And the best part with the data frame is, suppose I have another record which I have to put as a profession. There is no profession here, and I want to add a profession to this data, something like this. right? Data, pandas, and the profession I have added. So I can add the profession, and what I have to do? Simply, I have to tell that okay, your data would be like this only. So what I have done is these are the profession. What I have done is for data pandas. Data pandas is what was generated. Profession is equal to this. Now I print it. Just see. We'll be doing them again. So just an introduction I'm giving you. We'll be using it frequently. You can see that. Just added the column by giving the name. So if whatever name I give here will be added as a column, but you have to make sure that the data is same. Otherwise, it can be added, but it may not be meaningful. Okay. So this is what we have. Let me see what else we can do. We can do a few more things, but let's wait in. Let's see this one. The profession we have, and if I want to put, let's say, what I can put, I can put the mobile numbers. Okay. These days we do not have any telephone numbers. I'll just copy. I'll replace it. 6, whatever number. I'm just randomly putting the numbers. Because I don't have, I'm just putting a space there. What happens? Let's see. The data may not be correct. That's okay. Let me know. See, I had not given the number here, so it has taken it as a blank. And rest it has taken. Okay. So you can add the data. So we have many manipulations with the data we can do. We can add the data. We can drop the data. We can put the values in the data, and we can go to the locations. We have already seen in the list and all. iLock, a lock. We have LOC or iLock. We have that is integer location or location of the using the strings. You can have the label you have, so it can be used like that also. So we have the tools which are important. There are actually 3 4 only. One is your numpy, which is there, which can be used to convert the things, and for mathematical calculations we have numpy. Then we have skippy. This skippy may not be used, but most of the time. But in case you want some matrices to be generated, so you can use compressed matrices. You want that you can use skippy. Otherwise, there are other tools also. But this is not one of the very essential ones. But NumPy definitely is. And then we have the matplot library. So whatever you are having your plotting requirement, you can use matplot like to plot the things, right? This is what is there. Then you have the pandas. So you have profession as pandas. You can add it later. Something like this. You have. I'm just giving the example here. Bracket. So the square brackets you can put. Slowly you can creating here. So you have the name and all. and you can see that data frame, without a data frame, how the data would look, dictionary format, and then we have the data frame pandas pd dot data frame, and the value can be the data can be converted into a tabular format, and then it is easy to save it also in a file, right? In a CSV file or an Excel file, it can be converted easily now because we have the labels, the column heads, column labels, and the data, the rows. So it columns and labels can be pasted there. Then we have we can add also pandas data profession, and then we give the profession. We can add it, or we can have put the profession again. I should not have done that. This is the mobile number. You can see that profession has been replaced by what I have given. Mobile. But if I run it now also, the profession will be there. Just see. And the mobile will also be there. So what I have to do is I will have to run it again here. So I'll have to actually do it from here itself. Yeah, I'll have to run this first.
So you can delete also, right?
Yeah, you can drop the columns. Simple. Dropping is very simple. Destruction is always simple, na? You can use del command. I used it also, I think, when I was talking about the list now. The lab, I think I've already taken that, but I'll be taking it again because it is required. You can see now the profession has come, and now it is actually, it was mobile, so I can use it. I can simply drop the column just by the name. I can drop. You can do that. I'll be taking the things in the lab actually. So I'm just giving you an introduction here and to practically use the things and the tools we will be using frequently. There are two things which are already we always call, that is Numpy and pandas, and rest can be okay, fine. You can simply see if it is required, then you can whatever module is required, you can call that, right? So what we have done for now, let me correct it also. So we have seen some algorithms, that is the naive bias. Naive bias, I think I have not put it properly. Okay, yeah. Right. So we have naive bias algorithm, then k-mean clustering, support vector machine, logistic regression, ANN, then this decision tree, then we have the random forest, then we have the tools. So there are many more algorithms actually. Linear regression is also there. There are many algorithms, very many more algorithms than what we have shown here. But the idea is simple. You take the data, divide the data into learning set and training set, and then you can do that. Learning or the training set and the testing set you have, then you can simply uh, uh, train and test the data, train the data, the training set, testing set, the output which is which you have, you can use a validation data set on that, or validation data you can use and get the probabilities, the outputs, or you can just classify and just stop there. Now I'll just give you an interesting tool. It is called MJLearn. Okay, and this MJLearn tool can actually do things which you would be doing using the algorithms properly. But since this is an interesting tool which is actually not covered in many books, but it was designed and but I'll have to install it. It was designed for a book actually, and for the to run their examples, I've put there also a link from where you can actually see, and you have to, whenever you are installing something, a module, you have to use pip with a colon in the collab. Okay, pip install and learn. I'm just installing and showing you how we can also until okay, learn. That's okay. Now I can run it and see how it is installed. The module will be installed, but when you are using Collab, it will be only till you are using it. Once you close it, the module will go. Okay, so it will install, it will see the requirements. You can see the download, it downloads from GitHub or whatever the repository is. It is a tar file, a zipped file. Then it builds the wheel, and then you can see that successfully it has installed, and now you can use it. Okay, so let's see an example. We can use an example. First thing is import. So import any module you want to use, you have to import it. Now you have imported, and the interesting part is it already has some data sets inbuilt, so you don't have to do anything. What you do is mjlearn.datasets.load and load extended Boston dataset I have, which is there with the mjlearn, and it is very commonly used. Boston dataset is very commonly used by the trainers, the universities. You can see, yeah, I've worked with some UK-based university. They also were using the same data set for their students. And let's see first what the data is all about, and then we can use the classifier and plot it. Simple. You can see the shape. The Boston housing price data set has ethical problem. You can refer to the document. Import pandas is PD numpy. There is some ethical issue. That's okay. That is working fine. There's a warning, but it will work. I just have to plot it actually. So I just want to plot it and see. I'll show you actually KNN. I just wanted to show you KNN. So I've used it. K nearest neighbor. See how many neighbors we have. See, the data was already there. It is a housing data. So we have you have the test prediction, and we have the training class and training class 101. That is 01 we are talking about. The test 0 and test prediction 0 and 1. So that is there. Stars, you can see that how it is working. Clustering neighbors, number of neighbors is 1. You can increase the number of neighbors and see that how it would work. Okay, so you can have something like this. I can actually put some more things here. I'll increase that number of neighbors and see how many it can take. Let's have it as 4. You can see this, how it is connected, how it is connecting rather. The number of neighbors I can increase, and I can increase it more. I think I can have something like 8. Let me see. It should be 10 actually to connect. And what happens if I increase the related data should be there. You can see it will interconnect also. The moment I'll increase, the data will be interconnected also. Increase it further to 16. I'll just double it, and we'll see that how the cluster will be created now. See how only one guy is left. I wanted to cover everyone, but this person is standing out. Let me see if I can get it in. Is it? Is it to? I was increasing. Okay, let's see if I can get it in 20. There's only one person out. Now it is connected. Fine. Okay, so you can see that how the data is connected in Canon. Canon's neighbor, how it will be connected, how it can be used also. Okay, so I'll just put some text with that, and I can put the parameters also, how the Canon is used, because it is there in your syllabus also. mglearn I've used to plot, and KNN algorithm is it is the simplest machine learning algorithm actually. It depends on the probability of parameters of the things to be same, and then I can have a few things with Canon. I'll take it a little more. We have what the advantages are and what the disadvantages are. This is where with every algorithm. I just give you an introduction of the algorithms we have, but it is there with every algorithm, the advantage and the disadvantage. And that I'll give you as a task to find the advantage and disadvantages of the algorithms we have done today. So let's see who can find out and who can tell me. Okay, so parameters we have already seen what parameters we have used. So the advantage is one of the strength of KNN is that the model is very easy to it is easy to understand. Definitely, it's very simple, and reasonable performance is what you get from KNN. It's okay. It's not. It may not be very good, but it is average. Is okay. Overall, if you look at the accuracy, then all in all it's not bad. Okay, and the disadvantage we have, I just wanted to put some numbers in there. In a smaller data set, the building is very small, easy. You know, you can actually build the model very fast. Okay, when the data set is small. Okay, but as the data set grows, it takes time. I've seen it I was using an example a few days back where my data set was large and it took me almost 4 hours to build the model. It took a lot of time, so it takes time. So sometimes they're not good, but output maybe. So either there are more features, if there are 100 or more features in the data set, then this wouldn't work fine. It works on a very small data set, a sparse data set, or sparse features, you can say, small features. For a small feature, it can be of advantage, and since it is fast on a smaller data set, and if you want to test, for the testing purpose, Canon would be an ideal solution. K-nearest neighbor would be an ideal solution for testing purpose, but once the dataset grows, it won't work fine. The reason being, it will be slow because the features will increase. And once the feature increases, then the finding the nearest neighbor would be difficult. You can see that. I'll have to increase the iterations. Neighbors have to increase. Once I increase that, suppose it is 100, it will take more time. I can put I can try with 100 here, but that is a very small thing. But I just have see what will happen. It won't fit at all because there are nothing like to fit. So I'll have to limit it to my limited. Let me have it only 20. It was working, it's fine. So you have to see a lot of things. You have to see when you are using your machine learning or deep learning or transformers or anything, cognitive learning, anything, the most important part is your data. You can see that in any algorithm, in anything, what is important? It is the data which is important. If you have the data properly arranged, then you can always actually mm, get the desired outputs. But if the data is not properly arranged, then the outputs would be disastrous, and that applies everywhere. In data, like in exams, if you're preparing for an exam, if your brain does not have the data of the paper, it won't work. Simple. Or if it has marginal data, small data, it won't work. If it has in between, you can say half of the data, again it won't give you the best results. But you have the all the information that the data is pure, is clean, clear, and the output would be good, the results would be good. So it is basically all on your data. So what data you have, what output you want, they are all interconnected, they're correlated, interconnected, right? Everything depends on data itself. So if you have proper data, then you can actually work on it in a better way. So results will be better once you have proper data. And then, as I told you, you have to divide the data into training set and testing set, right? In a ratio which is good for classification, regression, or whatever you want, or the probability you want to have. So it all depends on that. All depends on the data you have and how you are managing the data, right? So I think I'll be taking the lab tomorrow, and I'll be showing you more applications. And I can stop the recording now, I think, because recording is not required now. Okay.